So now this u and v and this v will be cancelled from both the sides. Okay, so therefore on the left hand side, if you take rn square by 2 common, then it will be rn square by 2 equals to 1 by u plus 1 by v equals to n lambda by 2. Therefore it gives us rn square by 1 by u plus 1 by v equals to n lambda. Okay, or 1 by u plus 1 by v equals to n lambda by rn square. Okay, so now you see, now if we apply the usual sign convention, that is, if you look at this diagram, generally what we do, we measure the sign of u and v. You know, I already used u and v while you were using lens. So generally at the place of RPQ we would have placed a lens, and O will be the source and I will be the image. Then what is the distance of the source O from the pole from the lens? We go in the we go from the pole towards that point. Okay, so it is opposite direction of the propagation of light, so we take it to be negative. But while measuring the distance position of the image eye, we start from pole and go towards the image, and it is in the direction of the propagation of light, so it is positive. Okay, so using sign convention, okay, so we have 1 by v minus 1 by u equals to n lambda by rn square. Okay, or we can write it in this way, vn 1 by v minus 1 by u equals to 1 by fn. Okay, where fn 1 by fn equals to 1 by fn equals to n lambda by rn square, that is fn equals to rn square by n lambda. Okay, so which is very similar to the convex lens formula. Okay, it is similar to the convex lens formula of 1 by v minus 1 by u equals to 1 by f. Okay, so thus the zone plate, we can say that behaves like a focal length. Okay, so thus the zone plate behaves like a focal length, convex lens. Okay, like a convex lens of focal length fn equals to rn square by n lambda. Okay, so you see, if we put n equals to 1, we get the first zone. Okay, so we get a 1 focal length f1. If we put n equals to 2, then we get another focal length f2. If we put n equals to 3, we get another focal length f3. So in this way, see, for various zones the position of focus will be different. So that's why it is said that a zone plate has multiple foci. Now you see, we had this relation, that rn square into 1 by u plus, if we don't use the sign convention, equals to n lambda, which gives us the value of rn square to be n lambda by 1 by u plus 1 by v, which is n lambda ub by u plus v. Okay, now since this u, v and lambda are constant for a given light, for a given fixed object and fixed image, object means fixed source, then rn square is proportional to lambda. Okay, that is Rn is proportional to root over m. That is the radii of circular zones is proportional to square root of natural numbers. Okay, so that is why if we want to observe the focusing action of the lens, we have to these circles on the zone plate have their radius proportional to square root of the natural number. Okay, so we can see that it is clear that from this relation that the radii of the zones are proportional to the square root of the natural numbers. So that is why a zone plate is constructed. We can say that a zone plate is constructed by drawing concentric circles with their radii proportional to square root of natural numbers. Okay, so at RPQ, if we place along the plane RPQ, if we place a zone plate, then we can observe a bright image of O at I. Okay, so the light rays will be diffracted through the transparent zones of the zone plate, and after diffraction they will superpose at I, where we can observe their resultant effect, which will be a bright image of point O. So in this way the zone plate acts like a convex lens.